All right, we are now going to solve the initial value problem, y double prime minus 6y prime plus 25y equals 0, with the initial values of y of 0 equals 3 and y prime of 0 equals 1. This problem is going to have complex roots, so we just want to do another initial value problem example where we have the complex roots and the sine and cosine in the solution, just to see what that looks like. So we're going to have r squared minus 6r plus 25 equals 0 for our characteristic equation. This we will see is r equals positive 6 plus or minus the square root of 36 minus 100. 4 times 25 is 100 there, all over 2. Then 6 divided by 2 is 3, plus or minus 36 minus 100 is 64. The square root of that is, it's negative 64. The square root of that is going to be 8i. Divide that by 2, and we get 4i. All right, so our general solution, we can jump straight to, I'll just rewrite the form again up here. So we can see that one more time. Given an r value that's complex of the form a plus or minus bi. So there's technically two different r values here, but the plus or minus doesn't matter on which one we choose. We choose the a value and the b value here. And the general solution has the form y sub g of t equals e to the at times d1 cosine of bt plus d2 sine of bt. Close out our parentheses here. And so plugging the 3 and the 4 in for a and b into this form, we get e to the 3t times d1 cosine of 4t plus d2 sine of 4t. And just as a heads up, you need to memorize this. That will not be given on an exam for this class. All right, so I'm going to take the derivative of y, so I can plug in the initial condition y prime of 0 equals 1. When I take the derivative, I'll do the derivative of the first is 3e to the 3t times the second d1 cosine of 4t plus d2 sine of 4t. Close that out, plus the first e to the 3t times, in parentheses, the derivative of d1 cosine of 4t is negative 4 d1 sine of 4t, plus the derivative of d2 sine of 4t is a positive 4 d2 cosine of 4t. Close that out. So I'll go ahead and plug in my derivative here. I get 1 equals y prime of 0. So when I plug 0 in here, we're going to get 3 times d1. So cosine of 4 times 0 is cosine of 0 is 1, so we just get a d1 there. The sine of 0 is 0, so that second term inside these parentheses is going to cancel out. And I'll have a plus. E to the 3 times 0 is just e to the 0 is a 1, so I don't need to worry about that. Inside these parentheses, the sine is going to cancel out the first term. The second term is going to be 4d2 after plugging in 0 for t and getting cosine of 4. Cosine of 0 is 1. Going up to the original equation, we can plug in y of 0 equals 3. When I do that, I get 3 equals d1. And that's because the sine of 0 will cancel out. E to the 3 times 0 is also a 1, so that doesn't come into play at all here. So we just have d1 equals 3. I can then plug that into the y prime initial condition to get 1 equals 3 times 3 plus 42. I'll subtract the 9. That'll be negative 8 divided by 4 is negative 2 equals d2. And so our particular solution, y sub p of t, is going to be e to the 3t times d1 is 3 cosine of 4t minus 2 in for the d2 sine of 4t. And that's all we have for this problem.